In problem 4, we want to know if year-end bonuses are different than 125,500. So this is a two-tailed test. If the mean year-end bonuses of a particular company is different than 125,500, then the alternative hypothesis is true, and it would be the mu is not equal to 125,500. The opposite of that is mu is equal to 125,500. Now, because this is a two-tailed test and sigma unknown, now, why do I know it's sigma unknown? Because this sentence starts with a random sample has an average of 119,250 and a standard deviation of 33,323. Now, because this is a two-tailed test and sigma unknown, the significance level has to be split in two, and the critical value will be found in the column corresponding to alpha divided by 2.025, and the row corresponding to 52, because degrees of freedom for this problem is the size of the sample, 53 minus 1. With a sample size of 53, the degrees of freedom are equal to 53 minus 1, and the alpha is divided into 2. So we got to go column 0.025 and row 52 to get the critical value. In column 0.025 and row 52, the critical values are plus or minus 2.007. So in part B, I pasted in the critical values, plus or minus 2.007. In part C, I need to enter the answer for the point estimate of the population mean. The point estimate of the population mean is not equal to 125,500. It is 119,250 because we're testing 119,250 against 125,500. We're going to copy 119,250 into part C without a comma, because sometimes Cengage now does well with commas and sometimes it doesn't. And we're going to paste it next to X bar. The sample standard deviation is 33,323. The sample variance is just the square of the sample standard deviation. The hypothesized value is 125,500. The point estimate of the difference between the sample average and the hypothesized value is a negative $6,250. The variance of the sample mean is less than the variance from the sample because it's the estimate of the variance of the variable divided by the sample size. The standard deviation of the sample mean, also known as the standard error of the mean, is the square root of the variance of the sample mean. The test statistic is the point estimate of the difference between the population mean and its hypothesized value and the standard error. Next, we're going to copy in the point estimate of the difference. We're going to copy that into Cengage now. And we need 0 decimal place accuracy. Next, we're going to copy in the standard error of the mean. And we only need 2 decimal accuracy. So if I get rid of the 6.1, I'm going to make that 6.7. Then we got to copy in the test statistic to 4 decimal places. To conclude in part G, we have to compare the value of the test statistic to the critical values plus or minus 2.007. If the test statistic is in between plus or minus 2.007, then this difference is insignificant. And we have evidence in support of the null hypothesis. So that is the case. The test statistic is in between these two values. So we cannot reject the null. Since we cannot reject the null, we cannot say the alternative hypothesis is true. Thus, you cannot conclude that the year-end bonuses paid by Jones and Ryan were different from that of Wall Street securities firms. We check my work. We get all questions right.